Hi everybody! Today we're going to be talking about organic chemistry molecules and how to name them as an introduction to alkanes. So alkanes are these long carbon-carbon chains that you might have seen if it's your first time taking organic chemistry. Something important to know is that they do have hydrogens that are usually not going to be written in, so just remember that if you see one of these carbon-carbon bonds and it doesn't have 4 bonds, the other missing bonds are going to be replaced with hydrogens that just aren't shown. So your ending for these long chains for your naming scheme is going to be ANE. And for the prefixes, by the way, I got this off of Socratic.org, great website if you need help finding information. The prefixes are going to be these 10, these are your main 10, and you will just put these at the beginning of your name scheme depending on how many carbons you have. So I just count the points of the carbon, and then you would find the corresponding number. You are going to probably have to memorize these. Most professors will just make you memorize these, so good thing to know. I'm going to skip us over now to the whiteboard feature, and we're back here with the whiteboard feature. So I just grabbed a couple examples. These are pretty like step 1 examples of how we would name these. So remember, since these are all alkane chains, they're just carbon and hydrogen, at the end of our naming scheme, all of these will get this ANE. I didn't write it down here for the last one, but that also has ANE. So we're just going to start with the top left. Let's count here. I'll write it down. 1, 2. And if you see that chart, you'll know that 2 is ETH or eth. So this molecule is ethane. This molecule would be 1, 2, 3. See how we have these 3 carbon points here? So that would be PROP for propane. Now due to time, I'm going to let you guys see these and try to figure these out yourselves while I switch us back into lecture mode. Okay, so we're back in lecture mode now, and you might be wondering, because you saw these examples at the beginning, what do you do if there are more branches or there's not just one big chain? So for that, you have to find the parent chain. And the parent chain is going to be your longest continuous chain. So let me show you what I mean by that. Okay, so for our parent chain, we're just going to start with this top example here. What you'll want to do, let me see if I can grab maybe yellow, is highlight what looks like the longest chain. So this one definitely looks longer than if we went the other way and used the top. So then we'll count 1, 2, 3, 4, 5, 6. So we know that we're going to have hex, because that's our prefix for 6. And we're still going to have ANE, because that's our ending. Now we're going to get into what do we do with this group right here in just a couple slides. So don't worry about this just yet. We're going to get there. We have another one down here. So let me look at this. 1, 2, 3, 4, 5, 6. So if you go across, you get 6. But if we go up and down, 1, 2, 3, 4, 5, 6, 7, we get 7. And that's more than 6, so we're still going to have our ANE ending. And 7 is HEPT, heptane. So just be aware that professors or on tests you might see the chain kind of branching and not just going straight across. So let me switch us back to lecture mode and I'll tell you what to do about these weird side substituents. Okay, so I have a couple kind of hints or guidelines here for how to name your substituents. So what you want to do is you want to find your big parent chain, and then you want to number your substituents, and you want to have the lowest number possible for all your substituents and make them alphabetical. That sounds pretty confusing, but I'll show you guys with a couple examples to help make that make more sense. Okay, so we're back here with our examples where we didn't quite know what to do with these branches. So we've already got the first step done, which is to find the parent chain. Now we need to number to get to our substituent as fast as possible. So if you start from the left, you'll get 1, 2, 3, 4. But if you start from the right, you'll get 1, 2, 3. So let me draw in 1, 2, 3. So now we know we're going to have something on our third carbon. So we can actually write in right now 3 and a dash. Since there's only one substituent, we don't have to worry about being alphabetical or putting things in order. So since this is just one carbon, it's going to be a methyl group. So let me write that. And you add YL, this little ending here, if you're adding or talking about something that's not the main parent chain. So main parent chain ends in ANE. Any side substituent ends in YL. So the full name for this molecule right here is 3-methyl hexane. So you just put it all together. So now we're going to do the same thing down here. We're going to try and count to get to our substituent as fast as possible. So here we have 1, 2, 3, 4, and here we have 1, 2, 3, 4. So for this one, it looks like it doesn't matter which way we go. So I'll just go this way. But again, they are tied, so it doesn't really matter. So we have something on 4. So we're going to write down 4. And just so you know why I'm putting these dashes, you always separate the dashes, the numbers with dashes. So if you have a number, always put a dash before and after it. It just kind of helps when you start getting really big molecules to keep things in order. So here we have 2 carbons branching off, so that's actually going to be ETH or ethyl. If you look in the chart, if you don't know that yet, that's fine. So this will be 4-ethyl, and then we'll put it together. 1, 2, 3, 4, 5, 6, 7 heptane. So our entire answer is 4-ethyl heptane. And one more time, remember, if it's a branch, it ends in YL, and the main chain ends in ANE. Let me switch us back, and I'll talk a little more about more groups you might see. Okay, so the question that's going to get asked next is, what do you do if you have more than one branch or substituent? So it's actually not too difficult. What you're going to do is the same thing. You're just going to find your parent chain, and then you want to get your substituents to have the lowest numbers possible. So you just want to get there as fast as possible, and then you need to make sure you're going alphabetically. So I'll give you a little bit more talk before we do some examples. So these are the common groups that we're also going to talk about. Alkyl halide substituents, nitro groups, which are just NO2s, and rings. So alkyl halides are going to be your group 7 over here, and they're going to be just kind of sticking off your chain. So if it's a fluorine, or you will see it abbreviated F, you'll say fluoro, Cl, chloro, Br, bromo, and I is iodo. And you'll put that at the beginning before your big chain, just like you would with anything else. And the last thing to cover really quickly is rings. You've probably seen rings before, and the thing about rings is you cannot add them. So you can't say, okay, I'm going to have a 6-membered ring, and then I'm going to just add that to the rest of the chain. Rings are their own thing. So unless your ring is bigger than your chain, your ring is just going to be a substituent. So you will just count those carbons in the ring, and you'll add cyclo as a prefix. So I know that was a lot of information, but we'll do a couple examples, and hopefully that'll help. So first, we're just going to do an example of if we have multiple substituents. So on this chain, you see we've got 2 different things branching off. And I did want to say, just watch out. This parent chain does go straight across, but they might not always do that. So we'll just go 1, 2, 3, 4, 5, 6, 7. Looks like that's going to beat everything else. 1, 2, 3, 4, 5, 6. Yep, 7 is going to be our parent chain. So let me just get our ending here. So remember, our very end is ANE, and then 7 is HEPT. So our very ending is going to be heptane. Now we need to get to these substituents as fast as possible. Let me circle them just to make them really obvious. So if we start from the left, we'll have 1, 2, 3, 4, 5. But if we start from the right, we'll have 1, 2, 3, 4. So let's do that. So we'll go 1, 2, 3 here, and we'll just put 4 up here. So 4 is, well, I don't like that. We'll do 4 here. 4 is here. So now what we're going to do is we're just going to put our pieces up here. So we have a 3 dash, and remember this is just one carbon, so it's a methyl. So methyl. The YL is because it's a branch. And on 4, we're going to have an ethyl. ethyl, because it's a branch. Now we have to make sure that we're doing it alphabetically, just because we have more than one thing. So I'm going to bring these pieces down alphabetically. So we're going to be doing 4, and then don't forget your dash, ethyl, and then 3, but we need another dash, 3, methyl, heptane. So our full answer is going to be this right here. It's more important that you have things alphabetical than in numerical order. Alright, next we have a couple common groups. So I just wanted to do these really quick to show you what they might look like. Let me grab our pen and get our pen working here. Oops, sorry about that. Alright, so for fluorine here, up here, we see there's a fluorine group. So we'll know this will be FLUORO. And chloro will be CHLORO. And bromo, EROMO. And iodo, like that. I don't have enough time because I've got a 15-minute limit, so feel free to try to finish these on your own. Here are the rings that you're going to see. So this has 3. So all of these are going to have cyclo at the beginning. CYCLO. Sorry, cyclo. Every single one has cyclo. Now since this one is 3, it would be cycloprop, PROP, YL. This here would be cyclobutyl, cyclopentyl, and cyclohexyl. But just know that the first 2, cyclopropyl and cyclobutyl, will not exist. Well, it's really likely they're going to exist just because of ring strain. Alright, we're going to get one hard example in, so we're going to start. So we're going to highlight our parent chain, 1, 2, 3, 4, 5, 6, 7, 8. 8, so we're going to get octane as our parent chain. I'm going to number in red for us. So as you can see, if we start from the left, we go 1, 2. We hit this faster than if we were going to go the other way. We'd get 3. So 1, 2, 3, 4, 5, 6, 7, 8. I've added in our substituent names, and I'm going to drag them for you so we can see what order they go in. So remember, these are supposed to be in alphabetical order, not numerical order. Just like that. And then don't forget your ending octane. So this is all one big term. Here's another example I had. I don't have enough time to do it for you guys, but I will give you a couple seconds and I'll give you the answer after a short pause. And just remember when you're doing this one that it is possible for your chain to zigzag, not straight across. So your answer for this one is going to be 2 bromo, 4 ethyl, 5 nitro nonane. Please note that there should be an A down here, but it looks like my keyboard doesn't want to type the letter A. Anyways, thank you for watching. Hopefully I can get my letter A key fixed before the next video. Good luck studying!